You're welcome to Studies. This is Extra Touch Global Media, where we give extra touch to those little clarifications you need for excellent studies. Please don't forget to hit the subscribe button to keep getting updates from Extra Touch. Today we are doing physics, and in physics, I want to quickly talk about one hidden law in physics that your school will not really teach you. Alright? One hidden law. So we're doing the SNELL'S law. Alright? The SNELL'S law is one of the laws that governs light. Alright? It's one of the laws that govern light. The SNELL'S law states that the sine of the incidence, angle of incidence is the sine of the angle of incidence divided by the sine of the angle of refraction is equal to the refractive index of given media. The Snell's law says that the ratio of the sine of angle of incidence to the sine of angle of refraction is constant as the refractive index. For a given pair of media. Please, physics is very simple. Please, it's very simple. Just make sure you're following extra touch global media. So the ratio of the sine of angle of incidence to the sine of angle of refraction is constant in a given pair of media. This constant that I just talked about here is what we call the refractive index. The refractive index. So specifically, you are going to have the sine of angle of incidence to the sine of angle of refraction is constant. This constant is called the refractive index. So you can add this to be refractive index. Are we together now? Then of course this is your angle of refraction. Angle of incidence. Then this is your angle of refraction. Alright? As simple as that. I've told you that refraction deals with the change in the velocity of light due to different densities in different media. Alright? The change in the velocity of light, and of course the velocity of light is 3 by 10 power 8 meter per second. Velocity of light. Velocity of light in vacuum is 3 by 10 power 8 meter per second. And this velocity of light is due to the density of what? Air. It's due to the density of air. So the ratio of the sine of angle of incidence to the sine of angle of refraction is the refractive index for a given media, a given pair of media. And hello, incidence angle and refraction angle can be interchanged by the principle of reversibility of light. Reversibility of the reversibility of light. So I say the angle of incidence to the angle of refraction can be interchanged by the principle of such interchanging occurs in physics by the principle we call the reversibility of light. Meaning that, light can travel in a path, create a reflection, then can still travel through that path of refraction to the what? The original path the light was what? Being sourced from. So that is what we call the what? Reversibility of light. And this also gives birth to the what we call the critical angle. What we call the critical angle in light. We have what we call the critical angle. It is called critical angle because at 90 degree, there is a specific angle of what? Refraction. At 90 degree, there is a specific angle of refraction. So if a ray of light is incident at 90 degrees, then the refraction is what? A critical angle. So you have a critical angle. So the critical angle is the angle of refraction when the angle of incidence is what? 90 degrees. The critical angle is the angle of what? Refraction when the angle of incidence is what? 90 degrees. And these are the basic principles that governs what? The Snell's law and refraction of light waves generally. The Snell's law and refraction of what? Light waves generally. Now, if you are given, if you are given angle of incidence, then you are given angle of refraction. You can simply calculate the refractive index of the media. It is very simple. Let's say angle of incidence for the media is 30 degrees. Then angle of refraction is what? 60 degrees. Alright? Then the refractive index to be calculated, you just simply use the Snell's formula. We call this the Snell's formula that we derive from the what? The Snell's law. So if angle of incidence is given, angle of refraction is given, this is very common in physics practical. Alright? Practicals on light. You always do this. Then you can also see it in physics objectives. So if you are given angle of incidence, angle of refraction, you can easily calculate the refractive index of the media involved by simply taking the ratio of the sine of incident angle over the what? Sine of what? Refracting angle, angle of refraction. And that will give you what? Sine of what? 30 degrees over what? Sine of what? 60 degrees. That gives you what? Refractive index. So you can repeat this for any given what? Media. Let's say they can change your angle of incidence to be 20 degrees, angle of refraction 50 degrees, you can give the angle of incidence 35 degrees, you can give the angle of refraction 80 degrees. Then for you to calculate the refractive index, you still take the ratio of sine of angle of incidence to sine of angle of refraction.